Hello, this is Professor Garner. I'm the lab coordinator for the Chem 122 labs. Today I'm going to give you a pre-lab lecture on experiment 21, which is the determination of a solubility product constant. So we're going to be looking at the silver acetate equilibrium system, right? So we're going to be approaching it by making a saturated solution of the silver acetate from different starting amounts of the two ingredients needed, silver and acetate. So in order to get the experiment set up, we have to make sure we have some clean and dry glassware. And so this is being done in a demonstration for you by Doug Walton, and we're going to see that in just a little bit. First thing we have to do is we have to get some of the ingredients that we're going to use to make our saturated solution. So we're going to take a 150 ml beaker, fill it to 100 mils with 0.250 molar silver nitrate, and another beaker where we have 100 mils of 0.300 molar sodium acetate. We're going to need to clean, rinse, and coat a 25 mil and a 10 mil volumetric pipette. And so the reason why we're having to coat it is if you have rinsed the pipette with water, right, the first time you put some of your solution in, it's going to dilute it. And so we're going to need to coat it because we're going to use these pipettes to get the silver nitrate portion of the solution. We're also going to then clean, rinse, and coat a 50 mil or 100 mil graduated cylinder with the sodium acetate, and then we're going to make 3 different solutions A, B, and C with these different amounts of the sodium acetate and the silver nitrate. We're going to put these solutions into clean and dry 250 ml Erlenmeyer flasks labeled A, B, and C, swirl them for about 10 minutes to make sure that the equilibrium is established and it has a saturated solution. We're going to then dry filter these solutions into 100 ml beakers with some stemless funnels, and we're going to try to make sure that we're collecting the filtrate, which is the aqueous solution. We don't want any of this solid material, so we're going to need to then pipette 20 mils of that filtrate solution into small flasks that are going to be used for titrating. We're going to need to prepare inside those flasks an indicator with some iron from ammonium iron sulfate, and we're going to need to make sure that that iron is acidified, and so the solution, when it was made as an indicator, it was made in 1 molar nitric acid, but to make sure that the indicator works, the iron works as an indicator, we're going to need to add 20 drops or 1 mil of 6 molar nitric acid, right? So then we're going to need to prepare a burette. So we're going to rinse, fill, and run air out of the tip of the burette with some of the titrant material, which is going to be a 0.0500 molar potassium thiocyanate. And then we're going to titrate with that potassium thiocyanate until the color persists for at least 30 seconds. Now, what's going to happen when we're titrating our filtrate solution with the potassium thiocyanate is that the silver is going to bind to the thiocyanate ion, and it's going to form a white precipitate. But what we're really after is to get a color change that turns to red when the iron combines with the thiocyanate ion once all the silver has been removed. And so what we're end up getting is a mixture of which that iron thiocyanate turns red, and so we get a mixture of the two colors, the white and the red, which should be an orange color. So when we are calculating the different concentrations that we're going to start off initially for these equilibriums, we're going to need to use a dilution-like formula, right? So if you have the volume of your silver nitrate and your molarity of it, and then you know the total volume that you dilute it into, right, then you can calculate the initial concentration. And same thing for the acetate ion, right? There are some volume or formulas for some of the calculations in this lab, but it's not clear that the volumes, if you plug them into the simplified calculation formulas in the lab, you have to make sure that you're plugging in those volumes in milliliters. I don't really like to use some of those formulas. I like to think about things from first principles, like, you know, how do I get this initial concentration, right? We also want to remind you that volume times molarity makes moles. And once we determine the moles of the thiocyanate ion, that will also tell us the moles of the silver ion. And so to get the silver ion at equilibrium, we'll just take the moles of the silver and divide by the volume, but in liters, and it was a 20 mil volume that we pipetted into the flask for titration. So that's how we do some of the calculations. Let's see how the experiment goes.
So we have our clean glassware here that we'll be using, that I've already gone ahead and labeled for each of our 3 assays, A, B, and C. So we have 3 of the 250 mil Erlenmeyer flasks, our 3 beakers with funnels for capturing the filtrate, and then our 3 Erlenmeyer flasks for the titrations. In this beaker here in front of me, I've already rinsed this with my silver nitrate solution and then put it in here. I took the liberty of already rinsing one of these pipettes, but I'll show you the other one and why it matters. So you need to make sure you clean everything. Silver nitrate likes to precipitate everything, and since we have halogens in our water, you will see that it will try to precipitate anything that's on the inside. My waste beaker. I've already made some nice precipitate here. And there's a nice stain on the inside here, so that should be well, it's not precipitating as badly as I thought it would. The other one was prettier. I should have done, if I'd only known. It had a lot of debris in it. Because what we're doing is we're using the material we're going to pipette to thoroughly rinse the glassware so that the only liquid that's been inside of here that it will come in contact with is itself. That way it will not react with anything until we're actually ready for it to react and cause our reaction. So you want to make sure there's no solid precipitate debris forming inside your pipette. And then I am putting it into this waste beaker where you can see, because I've already rinsed the other one, that there's some lovely precipitate. So this is what we're going to be collecting, lethal glitter. That's probably not a technical term. Okay, so we've rinsed both of those. I've already took the liberty of rinsing this graduated cylinder with my sodium acetate. I'll make sure it's sodium methoxide. Sodium acetate. So we are ready to do our aliquots. Right? So into the first Erlenmeyer flask, we are going to take our pipettes, and I need 35 total. Oops. And I'll be doing 30. So that's 35 silver nitrate in there. Now I need 30 into the I'll go ahead and do C because it's right here in front of me. I need 30 mils. Unless you're either really good or really lucky, you'll need to top it off with a pipette. As soon as we add these together, they're probably going to start reacting because they did in the waste container. We'll get to that in just a second. 25 into this one, to beaker B. And I'm not doing these in order. That will drive some of you nuts. Into Erlenmeyer A. All right, so we already have some death glitter forming in C. Wants us to stir them until it begins, so I think we've got some precipitation going. So, and then just intermittently, just to make sure we're still colliding our reactants with one another so that the reaction can continue. These will not need to be swirled as often as our filtration. All right, after 10 minutes of precipitation, we have this lovely cloud of death in each of our Erlenmeyer flasks, and we're moving on to our filtration step. So we have our stemless funnel in our beakers. This is A, and I've already taken the liberty of folding 2 of these just for your educational benefit. You fold it in half once, fold it in half again, and then if you take 3 of them on one side and 1 on the other, it creates a very nice party hat to collect your filtrate in. So we're not going to wet this down because we don't want anything in there except for our residual unprecipitated silver nitrate. And you pour this in here gently, and we're going to capture as much of the precipitate as we possibly can, and then capture the filtrate at the bottom, which we will then be titrating to find out how much is left. Now, if your lab manual says try not to get any of this on you, you'll notice I'm not only wearing a lab coat, which is super snazzy, I'm wearing gloves and goggles because for some reason, even wearing gloves, sometimes I get silver burns. Okay, so now while we let that filter, we're going to start the second one. And then while we're waiting for these to filter, I'll fill up our burettes. We'll wash them and fill them. Try if you can not to compromise the filter paper, because obviously if you rip it or put any kind of a compromise into the paper, you'll get precipitate down in the bottom, and that may skew the party hats. Are you not entertained? CSN is actually short for Clown School of Nevada. Wait over, Dean, here's them.
I like that.
All right, so now we have our burettes over here, and we need to rinse them with our titrant, which is 0.05 molar, see, that's why you wear gloves, which is 0.05 molar potassium thiocyanate. So first we're going to just put a little bit in here just to rinse the insides. I've turned the stop corks here just so that they'll collect a bit on the bottom of each burette. And we use that to make sure that we rinse the inside, and then we open this a little bit, make sure that we've rinsed out the tip of the burette and make sure there are no occlusions. It's a good time to find out before you get ready if it's stopped up and you need a new one. Also, this allows you to find out if there's one you like better than the other, which I didn't do last time and paid for it. And it looks like they're both free-flowing, so we're going to go ahead and finish filling them up. Remember, in your titrations, you're going to take two measurements. You're going to take your initial volume, which in both of these cases is 0 up here. We have these handy-dandy readers, which we'll get to in a second. I've just gone ahead and set these both to 0. And then our final volume, which will be somewhere down here. The volume, remember these deliver a volume, so it's measuring how much we have delivered into our reaction at the bottom. So the final volume minus the initial volume is the volume of titrant used. I can't believe I remember the word titrant. All right, so we have, I think all of our filtration is done, so now we're going to pipette 20 mils of each of our filtrations. I'm going to rinse them because, you know, I made a big deal of that earlier, and now I totally forget, right? Does that make sense? So we're going to use a little bit of this, and they say be sparing. Because we want to make sure if there's anything in this Erlenmeyer flask, you know, leftover water, leftover soap, that we precipitate it before we start our titration. Okay, so that's C. Do A next, because you will like that. Again, I need to rinse. Again, we rinse. So my lovely assistant's going to pipe at that one. Okay, now we're going to start our titration. So the first thing we need to do is add to both of these 2 mils of our ferric ammonium sulfate indicator. So we're going to add that via this graduated cylinder. Because at the titration endpoint, this also has a color change. And I have no idea. So you can already see the color that it's going to hold. So it's probably too fast. It's going to get sort of a rusty red color when it's finished. Go away. Strawberry quick. That's why you should never drink it.
You guys see the meniscus. We want to read. Remember, it's increasing going down as you go down the burette. So you're reading. Remember, each division mark is worth 1/10 of a milliliter, and you have to be able to record if it's in between those division marks, the next position in the number. So this was flask A, titration A, or sample A. our initial volume in our burette is 0.00. And now we're going to titrate sample C, and then we'll have to redo B. All right, so actually sample C has finished its titration. It's a little bit darker than multitasking. And now we're going to be able to catch the volume in the burette, right? So here we have, again, numbers increasing down, right? It's between the 21 and the 22, and you're having to read the bottom of the meniscus and the minor division marks, okay? And so it's just about above the halfway between 21 and 22. So you can take that down in your lab notebook. That was for sample C. Now for sample B, initial volume is 0.00 milliliters. And now we're going to titrate sample B. All right, reach the end point. This is for repeat of sample B. Okay. We've got the orange color persisting for 30 seconds. And so we're going to try to look at the meniscus again, right? So major division mark that we're past, we just went past 30, so we're between 30 and 30.5. So we're trying to see if we can read the bottom of that meniscus, right? Straighten this up a little. The lighting is not great, so I'm going to help you see what I get when I put it in the yellow. Maybe that will help. Yeah, that's better. All right, so now you can see it's just past 33, and we're trying to get the bottom of the meniscus, right? I would say that we have gone somewhere between 0.2 and 0.3. So you make your reading now in your lab notebook. All right, so from here, the rest of the lab is a dry lab. You're getting some data for different temperature titrations that we don't actually do in the lab. It's a dry lab, right? So so that's for part B, the temperature dependence of the silver acetate system, right? So you're going to go ahead and use the data given there to complete the calculation. All right? See you later.